Thank you so much for joining our virtual discussion and our talk. I know that we would all love to be in person at SME. I think this is my 10th year attending a conference, so definitely a little bummed that we can't see each other, but I'm very excited today to talk to you about a topic that is near and dear to my heart. That's deploying sensor-based sorting solutions and our experiences in the field. My name is Jordan Rutledge, and I am from Tomra Sorting, and our office is based in Golden, Colorado. So I promise that I won't read this abstract even at all. I just wanted to put it in our presentation in case anyone wanted to see the original transcript that we wrote and why we decided to choose this topic. So giving you a quick outline of what I'll be talking about today, starting with what is sensor-based sorting, why do we use semi-mobile solutions, some installation suggestions and guidelines, and examples from the field. So starting with what is sensor-based sorting. So sensor-based sorting is for coarse particles. They're detected by a sensor, imaged and characterized, and generally these are separated using compressed air. There's two distinct streams, product and waste. When are you going to use sensor-based sorting? Generally when there's useful liberation between about 1 millimeter to 250 millimeters, so that's about 1/8 of an inch, all the way up to about 10 inches. Why would you use this? To increase your head grade or upgrade your valuable material, to increase your life of mine, and to decrease the consumption of things like water, reagents, energy, and the generation of fine tailings. Finally, where in the flow sheet are you going to use this? Since we're generally operating in that 1/8 of an inch to 10-inch guideline, it's going to be after crushing but before grinding, or also potentially on coarse stockpiles to recover value from waste. So we covered the what, when, why, where. So who, we're generally going to say sensor-based sorting is more suitable for miners on the left than miners on the right. So how sensor-based sorting works. With vendors, you're going to see two main sorting configurations. These are just the mechanical configurations of the machines themselves. So you'll often see chute configurations with particle sensing techniques like color, laser, and near infrared. And then belt configurations, often with X-ray transmission or EM. It's two different ways that the machines are fed and imaged. They have drawbacks and advantages. It's kind of just different ideologies. But there's two different machines that you'll definitely see in the field. So looking at using semi-mobile solutions, first we need to understand the different types of sorting plants. So the first is going to be a static sorting plant. And this is where you have a fixed unit. It's often in operation streamlined with the rest of your process. So it's an integral part of your plant, and it's not going to go anywhere. So you have a lot of infrastructure and building around this. And on the other hand, we have semi-mobile plants. And this is often where you have a standalone unit in operation, and you're using it as a pilot plant. You're processing stockpile material, or a modular plant, or a modular component for your overall plant. So if we look at the benefits of using mobile units versus fixed plants, the biggest drawback here is going to be flexibility. The first thing to notice, financial, obviously, capital expenditures are going to be much lower for mobile units than they are for fixed plants. So just the steelworks alone and the other auxiliary components and kind of foundations and structures that you need, if you're able to do a mobile unit, that can often be really beneficial financially. Operational, the ease of implementation. So often here, there's no need to change or impede the current operations. So if you're able to do a mobile unit that is incorporated into the plant, this can be really helpful. Also scalability, so you're able to start with a smaller amount of material that you're processing and scale up easily from there. And finally, situational. So there's different areas or situations like pilot plants for research and development, where a mobile unit really makes sense as opposed to building a full-fledged structure. Another one of these examples would be multiple deposits. So if you have an area that you want to process, but you have different deposits or pits within a region, the ability to move the sorter to those different deposits is incredibly useful. And finally, waste pile processing. So if you have historic waste piles, a mobile unit is a great solution for that. So looking at some installation suggestions and things that we've learned from the field. So when you look at a sensor-based sorting unit in a container, you're going to see something similar to this. So you have your feed come in through the top of the unit into a vibratory feeder. That feeder feeds the machine where the material is separated into ejected or accepted. So you have your two different particle streams. These are going to be product and waste. You have your control cabinets and your chiller, and then some kind of substructure and walkways. Similarly, with a chute-based sorter, this takes up a smaller footprint, but kind of the outline is very similar. And you have your feed coming in to a vibratory feeder, goes through the sorter, and you have two different streams. So your accept and your eject. In this case, you're able to fit a lot of this auxiliary components that are needed to run the sorter in the 40-foot standard container itself. And in the next slide, we'll go over a little bit of what those auxiliary components look like. So in your general sorting equipment scope of supply, if we're looking at containerized units, you're probably going to get a vibratory feeder that feeds the sorter itself, the sorter, the control cabinet for the sorter, and then a chiller, and potentially a substructure. Now, other than that, there's many other things that we need to consider when looking at running a sorting plant. And those are going to be material preparation and handling, and then air quality and supply. And so on the material handling side, your sort is only going to be as good as the material that you put in and how you prepare that. So things like hoppers, conveyors, and screens are incredibly important for the sorter to run well, and part of the material or the equipment that you're going to be looking at when you're looking at running a sorting plant. The second is going to be air quality and supply. So sorters consume a lot of air in order to eject or separate out those particles. And so you want your air to be clean and dry and in high supply to make sure that you have enough to cover the operation of your sorter. Some other things that you might consider, any chute work for kind of transition points between material feeding, the substructure and the foundation for the substructure itself, and then any auxiliary equipment, paneling or instrumentation that you might want. So there's quite a few engineering companies that have started to design modular sorting plants. So taking the sorter and designing kind of a full-fledged plant with screens and conveyors and the whole bit. So here's a design by Halyard. This is for a chute-based sorter, and you can kind of see on the right-hand side all of the scope of supply of everything that's involved and included in their engineering design to make sure that the sorter runs well. Looking at some typical layouts, I like this example because you can see mobile crushing and screening being used. So we have an operator feeding your mobile crusher and screener. That material goes into a hopper for even sorting and distribution to your sorter, goes up to the conveyor, feeds the sorter, and then you have a product and a waste stream, which are taken away. So I like these time-lapse of photos as well. So this is a site up in Alaska that was preparing their area for the semi-mobile sorter. So in this case, you can see them doing some ground stability, putting and installing in those mafia blocks, starting to build the substructure and the frame of where the sorter will sit, assembling and putting on the guardrails, and finally loading the sorter onto that substructure and the final product. So some final other things and details that you might want to look at as far as installation goes. If you're going to be looking at a mobile unit, you definitely want to make sure your air compressor and generator are in a close and sheltered spot. So in the upper right corner, in this case, they actually house all of that equipment in a secondary container. So this is their container where their sorter is housed, and then they have another mobile container for the rest of their equipment. These two pictures up top show a really good design of transition and making sure that your material transitions are clean and easy. So the chute work for the inlet and the outlets. Radiation safety. So something quickly to note, if it is X-ray transmission machine, there is a lot of shielding built within the machine itself. So it should be very safe. The one point that we caution about is underneath the machine. And so this is why we have this fencing that's included into the design so that when the machine is running, people won't get under there or work under there. Finally, this customer actually fabricated a skid. They move their sorter quite a bit to different piles and stockpiles that they have. So they have this really easy to move and assemble substructure frame that allowed them to have their sorter. Finally, really important, having an internet connection is super helpful on the service side. So if there's any problems or issues with the machine, the ability to log in remotely and take a look at what's going on can be incredibly helpful. Another big point that we talk about is dust. And so often you need to make sure that you're minding your permit. So because of the use of compressed air within the sorters themselves, there can be dust generation. Often this can be helped by good materials handling. However, there's still going to be some dust, no matter how good the materials handling. So in this case, we do supply dust extraction vents that are on the outside of the machines, and they're ready for dust collection implementation. But a dust handling system is something too that is kind of case and site dependent. Another thing is looking at increasing your throughput from using multiple sorters. So often we're talking about a pretty narrow particle size distribution for sorting. This has to do with the efficiency of the sort and the materials handling, but we often see that people will do containerized units in parallel to increase their throughput and do different particle size ranges. And if this is the case and you put them right next to each other, this simplifies your materials handling downstream because you're able to use the same belts for product and waste. So you have crossover belts that go underneath both of the machines to collect the material. And then you can end up with just two piles, of one of product and one of waste. Finally, to the exciting part, so looking at some of the examples that we've seen in the field and installations. First one I'll talk about is Anglo Ashanti in Brazil. And they actually use laser and X-ray transmission technology for their gold ore. They have sulfides and quartz associated gold. And so this is the reason that they're using two technologies. And in the end, they have about 97% gold recovery. And they're concentrating this in about 40% of the mass. So they reject 60% of their coarse waste right up front before processing anything else, which is incredibly beneficial, not only for their energy consumption, further down crushing and grinding, but for reagent consumption and considerations like tailings dams. Core Kensington is a gold mine up in Alaska, and they actually implemented sorting to process all of these waste stockpiles that they had from ball mill pebble rejects. So they had these historical piles that they thought might have value. They installed this mobile unit in order to start to process those millions of tons that they had. And the containerized unit allows them to operate and process these ball mill pebble rejects outside of their existing plant. So it doesn't impede or change anything in their current process. Other than that, they get upgraded feed from the sorter back into the mill, and then they have a true coarse waste as the waste product from the sorter. So their sorting implemented back in 2016 actually ended in gold production of about 14 ounces per shift, and that's about $2,000 per hour. So for them, it was an excellent use of their waste stockpiles to add value to their process. So finally, this is a really good story about a pilot plant that went into full production plant. So this is an integrated mine to power plant, and they generate about 1.6 gigawatts of energy, supplying power to about 2.5 million families in the Midwest in the US. They use X-ray transmission, and they had a sensor-based sorting pilot plant installed in 2019. The issue that they were looking to solve is that about 10% of their coal has low BTU values, but it also has a really high amount of silica, which is incredibly harmful to their process downstream and their burners, and causes millions of dollars in maintenance per year. So the sorting plant was a success at lowering the silica content and also increasing that BTU value. And in 2020, you can see on the bottom photo, they actually implemented this. It's still in a container, but it's now streamlined into their full permanent mainstream process. This is an example in South Africa. This is the P2ELG6 chrome mine. And you can see here, this is a nice aerial photo. So they have an operator feeding material. This goes into a screen and onto the vibratory feeder. You have your fines coming out, a waste, and then a product stream. And in this case, the main goal for P2E was to produce 38% lumpy chrome concentrate. And so they had been using DMS for a very long time. They looked at replacing it with sorting. And by doing this, they were taking low-grade material from about 20 to 28% chrome and upgrading this in excess of 40% chrome. One of the key takeaways here is that no water is needed and no reagents are needed. And from our customer, they said that we're producing small lumpy product for approximately 50% of the cost of the DMS plant. So this is an excellent example of where sorting can be used. Looking at the Karowe diamond mine at Lucara, one key interesting trivia tidbit is that they have recovered 4 of the 10 largest diamonds ever recovered in the world in the history. And they use tomer sorting technology to do this. So they actually have multiple containerized units in a modular setup. They're utilized in a fixed plant for the ease of implementation and cost savings as opposed to building an entire structure. Their return on investment was realized within 2 weeks after their installation when they recovered one of those largest top 10 diamonds. Oops. So finally, we are going to compare mobile and modular approaches and just compare and contrast the two. So when we look at mobile sorting plants, mobile containerized sorting plants, the benefit here is that it's flexible, it's easy to move and set up, it's going to be much lower cost than a permanent structure, and it's really well suited for pilot plants or research and development work. Additionally, it's great for stockpile or waste pile or reject processing. Finally, when we look at the modularization, so this is the example like Lucara, in this case, the benefit comes from building components that are made of similar size, they're standardized, everything is pre-assembled and numbered beforehand before it gets to site. So the installation and assembly is really fast, meaning that the plant comes online and production starts right away. One of our project engineers too had mentioned from his previous work in diamonds that the cost of doing a modular plant versus the full fixed plant is about a quarter of the non-modular approach. So it's incredibly financially sound to do some of these containerized solutions. Finally, thank you for making it to the end of our presentation. And if you guys have any questions, feel free to contact either of us. In normal times, we would welcome you to our office in Golden, but we hope that we can see you all soon. And thank you so much.